I'll go ahead and introduce everyone, and then let's take it off. So thank you everyone for being here. So we've been doing something very unique with Berkeley this summer. It's been a 4-week project, and this has been purely on data science. So as people in Volvo know that we are looking into the Janice, can you admit people into the lobby?
Yep,
so we've been working on a project for Google Analytics, so where we look at shopping behaviors, and we try to predict patterns and see if people would actually convert or not. And the biggest problem and that we face, biggest challenge in this case, and the students will talk about it, is the size of the data. These are tremendous. They're like a few hundred millions, so close to a billion samples, in order to make sure that they work and coming up with a generalized pipeline that works across a different sort of products. So in their cases, they'll show you that it's actually specific to 2 different use cases. So they've done a great job. Their work is not yet done, so we will continue working on it offline next week onwards. But I wanted to hand it over to Vanshi and Akhilesh. Please introduce yourself and take it away.
Hi. Should I go first?
Okay, I'll go first. Hi, everybody. Yeah, I'm Wenxi. I'm a student from IOR department for now, and for the past 4 weeks, I'm working with the DataX Volvo project, which is a very good project. Yeah.
Hey everyone, I'm Akhilesh. I'm a student at the School of Information. I'm studying Master in Information Management. So this summer I had the opportunity to work on a couple of projects, and this was one of the really likable projects amongst them. Definitely a huge learning curve for me, stepping from your academic background to the real industry scale background. So yep, it's been good. All right.
Okay.
We'll start.
Do you have a PowerPoint? Yeah, absolutely. Please go ahead.
Let me know when you can see my screen.
Yeah, it's visible. Just make it full screen. Yeah.
Yep. All right. As everyone knows, we're starting the project in collaboration with the Volvo Tex and SCET. We actually had 2 data sets at hand, and one of them was a cosmetics data set. Another one was an electronics data set. The cosmetics data set is the one which we primarily worked on, during the duration of these 4 weeks. But as Sohini mentioned in the starting, the goal of this project has to be to build a scalable pipeline in which you can input a data of any consumer behavior data, and you shall get the desired results, which is to predict consumer behavior at the end of it. And that is something which we have kept in mind throughout this journey, especially while we were talking about features. We were talking about what kind of the nature of data we were dealing with, because we wanted to ensure that we did not get stuck or hinged upon a particular feature in a, say for example, a cosmetics data set which would not scale to electronics, or say maybe to automobiles when we are trying to explore customer behavior. So keeping that in mind, these are the initial few steps which we took up, which was first of all the data cleaning, finding out the null values, and scaling the data to make sure processing is easy and ensure uniformity. Data balancing basically, what we did and what we mean by data balancing is that there was a huge disparity in the representation of the purchase versus the non-purchase labels. At the end of the day, what we are wanting to see is like how many people are purchasing, but the real data reflects, and what it reflects is that on an average, if I had to generalize stuff, 80 to 90% of the data is a non-purchase one. Only 10 to 20% you will be finding which is purchase data. So that can bias your model a lot and skew the results. So the step which we came up with was data balancing, to ensure that we are maintaining an good, if not an equal proportion of the purchase and the non-purchase data, right? And the last step which we did was pre-processing stages was the data transformation. Before I talk talk to you about what data transformation is. Here is another brief overview of our cosmetics dataset. It was roughly around 3 GB and like 21 million records, give and take. And
Hey guys, this is Isha. Sorry, I just joined.
all right, and in the so these are the different columns or the different features that we had, which we worked upon, provided to us from the original data set that we took from Kaggle. So yeah, what I forgot to mention, both these data sets, they were taken from Kaggle. These are public data sets which we worked upon during this month. And I've crossed off a couple of, if you can see, features over here. There are a couple of reasons for that. First of all, these features were having a lots and lots of null value, and they were not adding any value to our, you know, processing data set. And so these features were eventually dropped, and we are not taken into consideration while we were doing feature engineering and creating our model. Next, when we're talking about, the transformation, the last stage I was talking about here, the data transformation in the pre-processing, this is what we meant. So the data as it was available to us was on a transaction. The granularity of data was transactional. What I mean by that is that it was showing a single row would depict a transaction done by a particular user at a particular point of time with a particular product in a particular session. I just want to run you quickly through what these columns depict. A user session is what your typical user session on an internet depicts when a user logs into the browser or a platform. It can be from mobile device also. A limitation of this data set was we did not have a visibility into the channel the user was coming from or the source, like how was the user session captured. Was it a mobile data? Was it from a laptop, or was it from some different source? We didn't have visibility into that, and we didn't have visibility into like what accounts or what translates to the start and end of a session. It could have been anything like the user closed the browser or his token expired. So we had to make some assumptions and presumptions there while doing the processing. But a typical row here would depict for you that, for example, this user called 32, if example came into this user session and dealt with this product which belongs to this category, and he removed this product from the cart at this timestamp, right? And that was the amount of the product at this one. So while this was good, what we actually wanted to understand, what our intent here was, we were trying to capture the user journey, right? Like if we were trying to understand that if a user goes in and he deals with the product, and so this is cosmetics data set. Let's say, for example, if user is purchasing a moisturizer, I'm just taking a generic example over here, and does he end up buying that moisturizer or not? And what are the patterns under which he buys that moisturizer, as opposed to the patterns under which he will abandon that moisturizer in his shopping cart? And that's the abandonment behavior which we want to diagnose and help with. So we clubbed together and basically grouped our data to reflect the user journey, in which a user's interaction with one product across multiple sessions were bundled together, and then features were created to show his interactions with that particular product. It was possible that the user could go in and deal with the moisturizer and purchase it 10 times. It was possible that he would not just purchase it. He would just be viewing it 1,000 times. And these are some anomalies we have seen in our data. But we after discussions and looking at the goal of scalability, we found that it's best to club the data from a user and a product perspective. Like a user journey with one particular product would be one row of our data. Feel free to stop me at any point if you have like a important Q&A, but definitely we'll be doing a Q&A towards the end as well. The next step, of course, was to do the exploratory data analysis, and here's we did a lot of EDA. I'm just going to summarize some of the key results that we found in 3 slides. This is the first one. This one tells you across a session for a particular user what is the conversion rate and what is the abandonment rate. As expected, there's more abandoned, which is almost amounting to like 90%, actually 88%, and there's only 12% of the sessions of that a user goes and deals with a product, they convert to a purchase at the end of the day, right? Another key thing that I want to mention over here is that our data, like I showed earlier, was between October 2019 to February 2020. So these are like really fresh, really latest data. But there is some missing data at the starting of October and the end of February because of how Google Analytics capture it just was the capture started from a date, but there was data before and after that as well, which might not be present, analysis. This is your so this was time series data, definitely, right? And this is an analysis of the event history trend as it went from October to February. Uh, you can see, for example, for the purchase one, which is a green line, like how the purchase kind of spiked in November, and that was like a little bit of expected because November is your Thanksgiving time, but on a surprising and shocking note, your purchases dipped a lot in December. One would expect that across Christmas and New Year's, the purchase of products would increase, but the data was telling us otherwise. And consumer activity took a really big dip in December, but it was a November which was like the highest sale for this cosmetic brand, anonymous brand that we were looking at data for. Next up, this is for your, again, max sale and minimum sale across time period. So across October to February, March, which was end, how much of the sales happened between these dates, and this is the amount on the left-hand side for you. This one, what it depicts is like after we did some like this one, what I'm trying to show here is the relationship between your total number of user sessions and particular event sessions. So the first one, in the top left corner, it shows you the relationship between total number of sessions and purchase sessions. As you can see that, the number of purchase sessions tend to increase after, for some time if the total number of sessions increase, but then they kind of tend to flatten out. So what it depicts philosophically or qualitatively for us over here is that users, it is not necessarily true if users who have like done more number of sessions, it is not necessarily true that they will have more number of purchases. Up till a certain point it is true, but beyond that it just tends to flatten out. There's a much more linear relationship between the total number of sessions and cart sessions as compared to purchase. So in here it will be like, though you might not be able to make a strong statement, you can say there's a linear strong relationship between the total number of sessions a particular user does. So if I'm a guy going in to like I'm doing 10, 12 sessions, it's a probability that there's a positive correlation that my number of cart activities, number of items I've carted will increase with the amount of sessions increasing. But if you see to the bottom right of your screen, and that is the relationship between the cart sessions and the purchase sessions, there's a disparity between here. While the total number of sessions show a linear relationship with cart sessions, there's not a positive correlation between carting and purchasing, which is essentially what we're talking about, the carting, shopping cart abandonment, where, up to a certain point, people do end up purchasing things that they have put in their cart, but sometimes they just leave them be. And due to various reasons, which we, qualitative may or may not understand, but we're trying to understand from quantitative perspective. So while this slide is from a user session and, events, by events, I mean purchase or view and etc. This next one is from a product perspective. So this is kind of trying to map the relationship between the number of products a person views versus the number of products a person purchases. So for example, the blue line, if you have a look at the blue line depicts, on your x-axis you have got the number of products a person has viewed, and on your y-axis you have got the number of products he or she or them have purchased. And you can see that the strongest like kind of relationship we are seeing here is in the green curve, which is like the number of products a person views as opposed to that when they add them to cart, which is kind of like as similar which we saw in even sessions, but there's not such a strong relationship between the viewing and purchasing of products here. Next up, so these are the features. After this, we came up with, customer behavior, how many clicks, what event types, what's in the cart, product, like what was sales, was it a discount or not? For example, took into consideration holidays, like, and if there was any some time wherein this activity spiked, and the time, especially, year, month, time of day. Channel and location are two features which we would have like to have, but this is something we do not have in this data set, and that kind of limits our capabilities to explore or quality to understand users behavior more in depth. this is a full list of proposed features which we came up with in earlier. Why do I mention this as proposed features? It's because not all of them were finally incorporated in our the processing or modeling. One of the challenges here was the literally machine processing. Basically the processing available to us, and as so when you mentioned the starting, these are huge databases. The first one was talking about around say 25 million records. The second database, which is like about the electronics, that's accounts to more than 100 million records, even for just a couple of months. And even with a collab available to us, processing can become a challenge, especially while we're trying to calculate or derive features. And these features, they use group by and apply. While trying to calculate them, use group by and apply functions, and these are like memory heavy and memory hungry intensive functions, and they just sometimes jeopardize. So we had to take a call, given the constraint of time and in the best interest to come up with meaningful results, we had to restrict ourselves from various dimensions. And one of those dimensions was these proposed features. For example, if you look at the third last line at your screen, what we are having is these features like view to cart time, cart to remove time. Basically, these features would show you how much time an average user spends between a particular user spends between viewing an item and carting an item, or between carting and purchasing it. But these were like memory intensive to calculate and could not be incorporated, into our final model. But most of these have been. And how they have been incorporated, of course, we did the feature engineering and feature ranking. So we used two things to do, actually three, to the feature engineering, feature ranking. One was random forest. We used the ANOVA test, the F score, and the third was we did the L1 regularization to penalize features and find out which are the top 5 features. Thankfully, and as the data shows here, the features which are of the most importance on both these from both these tests are the more or less the same. While the order may change, the top 10 or 15 features remain the same, and they are these are features like interaction time. Interaction time is defined like how much interaction a person has with a product. Okay, if I start on Sunday and I end this interaction with my product, let's say even 3 months from now, that is my interaction time. If I just do and it in 1 second, that is my interaction time. What is the total number of sessions a person interacts with the product? Do I view product for 50 sessions and purchase in one, or do I just purchase it within 1 session? And like, what are the total number of sessions I'm interacting with? Number of total items I'm carting, number of total items I'm removing, viewing, what is sales. These are all the features that we came up with. And we of course did the feature weightage after. So this step was of course was actually done post we did the baselining, which was done using log regression. But so the event type here is a feature is basically how many total events a particular user is dealing with when he's dealing with the product. So let's say I was talking about the moisturizer beforehand, right? When I'm interacting with the moisturizer, am I doing view cart purchase? Am I doing view cart remove from cart, or am I just doing view purchase, or it could only be just purchase? The total number of events that I'm dealing with when I'm dealing with a particular product as a given user. And you can see that this feature had a huge weightage, and like although this was not extremely strongly positively correlated to like purchase, like it was not directly kind of like implying purchase, but it had a huge effect on our model, and kind of shows like good correlation with the eventual results of labeling and user journey as a purchase or not purchase. Then you got the later on the number of sessions in session view, how much as user views in particular session, and how much it removes, sales, and so on and so forth. So going in interest of time, we did the modeling was done in 2 stages. I'll talk about the baselining, and then when she will take it from the bidirectional LSTM. So we did baselining using 2 algorithms. The first one was your classical classification algorithm, which is like logistic regression. Data was scaled using the min-max scale, and we ran it on multiple cores or 4 cores, because otherwise the model would fail to converge a lot. So we had, and this is the results for your log regression model. The accuracy was after. So this one thing I want to state is that the testing that is done over here, the modeling that has been done, it has been done after balancing of data. I think I forgot to mention that earlier. It has been done after balancing of data to ensure that that there's an equal proportion of the both labels, which is the purchase, which is 1, and non-purchase, which is 0. So log regression gave us a accuracy of around 93%, and after balancing and precision of 95 and a recall of 92%. The next one which we did was with KNN. KNN was basically implemented with PCA, tried to retrieve the 95% variance in the data, and with the k equal to 4, tried with so we tried with 3 different k, 3 and 4 and 5. Couldn't try with much more or use the elbow method because of processing issues and limitations, unfortunately, to come up with an optimized number of k. But with k equal to 4, we had accuracy of it took a much stronger dip as compared to logic regression. The accuracy was 74%, and for the KNN here, with k equal to 4. All right. All right, I'll then hand it over to Wenshi, who will take it over from here and explain to you the Tensorboard and the modeling from here on.
Okay. So one thing that we did brilliant is also like the Tensorboard visualization. You can see the two pictures here. They're both after this mode, which is one data augmentation technique to deal with the imbalanced data. And the upper picture is before featured selection. When we put all the data into Tensorboard, you can see that there is no very obvious pattern or clusters for the data. But after we select our very good features, we're having a lot like 4 clusters, which means that we have different customer behaviors here, and we can find the patterns to predict. So next we will talk about the main model that we are using here, the bidirectional LSTM. So this is an extension of a traditional LSTMs that can improve model performance or the sequence classification problems. It actually takes in the same inputs and outputs as the traditional LSTMs, but you can see that with the addition of another recurrent layer that has backward connection. The backward connection is allows the model to learn patterns from the future, unlike the standard LSTM, which only has forward connections and therefore only allows making predictions based on the past states. So you can see that we have 2 layers of LSTMs here in a model structure. And after building other dense layers, and we can predict the classifier of the user and the product if they are buying or not. Okay, next page. So when we are training a model, we're using the grid search cross-validation to turn our parameters. And here we can see that after the cross-validation, actually the accuracy of the training set is pretty high. So let's take a look at what it looks like for the test data. So our test data is actually also having a very high accuracy with a good precision and a very impressive recall. So here we actually think it's more important to have a high recall because we want to predict correctly who are the customers that are actually purchasing, and we don't want to lose our customers. For those who actually will not purchase, but we predict them as purchase, we don't have actually a lot of loss here. Okay. And if we do the model comparison, we can see how all of our models performs here. Can see that the bidirectional LSTM is actually outperforming other models, and this is what we want. So as we mentioned, there were like hidden states that we can dig from the LSTM algorithms that can stand for different customer states. So maybe if we output the middle neurons of the LSTM, we can find out what are the different customer states, and maybe they can lead us to interpreting different customer behaviors. This is the result after we put the hidden states, the main neurons of the LSTM into the Tensorboard. We can see that the first picture is the forward and backward. So this is a concentrate of the backward state and the forward state of LSTM. It doesn't have a very specific pattern. The data points are very mass. And the second one is actually very similar. If we only have a forward layer for the LSTM algorithm, we are actually not predicting or finding any customer states or specific patterns. But when now we're inputting the backward states of the customers, we can see that there is a very specific and obvious patterns like clusters for the customer behavior. So we can see that there are at least 3 clusters of customer states, which means maybe there are 3 main customer states that stands for different customers' behaviors. Okay, so this is a very interesting and impressive result, and we think that we can do more about it later. So actually, we have another new data set about the electronics other than the cosmetics. And we did a little data comparison of the 2 data sets because we didn't have the time to dig the second one. So you can see that actually the electronics have a much larger data size, and for the category code and brand ones, they don't have as much NA values as the cosmetics do. So maybe later we can find more patterns in these 2 columns. And for the prices, we can see that electronics definitely have a larger and more spread price value compared to cosmetics. So this is what we can do for the future. And next, we have different events comparison. So we can see that for the cosmetics, we have 4 records, 4 different kinds of event types, including view, cart, remove from cart, and purchase. But for the electronics ones, they don't have any remove from cart events. They only have view, cart, and purchase. And we can see that attention that this is not across session purchase rate. This is only based on every record of the event. So there is fewer people buying the electronic products than the cosmetics. This is pretty normal because you have to view a lot before you buy a more valuable thing. And then about the categories, we can see that there are a lot of things from this electronics dataset, but it actually also includes some of the non-electronic things like the shoes, the oven, and we will deal with that later. And also the brands. Actually, for the cosmetics, you have a lot of brands to choose, and there are a lot of NA values. But for the electronics, the brands are more concentrated and like focused on the several very popular and large companies. Okay, so this is what we have for now for the new dataset, and this is a very interesting project. Aklish and I both learned a lot and found a lot of interesting things. So next we will also in the future work with the Sohani team, and we will focus on the model optimization. So for now, our bidirectional LSTM algorithm, we only use the cross validation for the optimizer tuning because of the limit of time. Later, we will also find our other parameters to optimize our model. And the second thing to do is to do the feature engineering for the new data set, because there are a lot of different things, even though that they are using same columns. And the third thing is to modeling for a new data set to see what is happening here. And the last is to think more about the customer behavior patterns or the states that we mentioned in the Tensorboard, because that is a very new finding, and it is really interesting to see that the neurons in the middle can present different customer behaviors. So that's pretty much it. Thank you for it.
Thank you so much, guys. That was really detailed. And I wanted to quickly mention that this is what the students have achieved in 4 weeks only. And so that there was a lot of work. There was a very, like they mentioned, there was a very uphill battle with processor and processing speed and everything. But we are really, I mean, I'm glad that they are really interested in finishing this with the second data set. And goal here is to be able to then submit a paper to IEEE Big Data. Hopefully the deadline will be somewhere in the end of August. So at this point, I wanted to open up for questions. If anybody has any questions, please go ahead and ask.
Hey, Sohini, I just wanted to comment on the progress the students have made. This is amazing. I mean, this body of work, I've seen this kind of research being done at eBay and at Amazon when they're looking at shopping behaviors and categories and deciding algorithms on which categories and how they should promote some of these things. And it takes years of work. So what I saw really impressed me, and appreciate all your hard work for doing such detailed analysis and thinking through so many different use cases that you guys were talking about. Thank you so much.
Thanks so much, Isha. It means a lot. And that's coming from the general manager of our office. So take a bow, students. Great job, guys. Any more questions?
Can you elaborate the Tensorboard, like, you know, the use of the Tensorboard, like what's your next step on this too?
Wenxi, did you want to take that?
Oh, yeah, sure. Actually, I didn't kind of. Okay, can you repeat your question again? Sorry. So you want me to?
Yeah. Can you elaborate like what part of the project you use for Tensorboard, like, you know, and also like you have any future planning for the Tensorboard?
Sure. So Tensorboard is pretty much for visualization, and we don't have very detailed data to extract from the Tensorboard. So before the modeling, we were using Tensorboard to see if there is any clusters that we can see, so that we can make sure that we are doing something meaningful. And you can see that after the feature selection and the balancing of the data, there is a very obvious cluster. So we can see that actually we're doing something very meaningful, because there is customer having similar behaviors in the same clusters. This is one of the things that we did using Tensorboard. And after that, in one of our meetings, Professor Ikla just mentioned the customer states. So Sohini just found out that maybe it will be very interesting to dig out what is the users like after you put the data into the algorithm, and then they will give you different middle states, and maybe the states can be like also clustered. That's leads to our second slide. Clear. Thank you. Yeah. So for the the Tensorboard one. Yeah. So using the bidirectional LSTM, we have actually 5 outputs, and the 3 of them are the 2 of them are the forward hidden states and the backward hidden states. And we can also concatenate them to the hidden state as the forward plus backward one. And you can see that if we are only using the forward hidden states is actually nothing. But so it actually proves that we are using the right algorithm if we are using the bidirectional instead of the traditional LSTM. Because if you are reading the data from the future and to extract the backward LSTM layer, you can see that there is very specific customer behaviors here.
Just one more comment to add here, Ao. So I think to finish Wenxi's answer, if you see the last graph here, once we have that data, what we will now do is we would do some density-based clustering, which will tell us that these are the, let's say, 3 or 4 cluster centers, and these are the cluster variances. And then for every single cluster, we will see what is the distribution of the people who purchased versus not purchased. And we are hopeful that we would probably find that there are few clusters that are showing more purchase behavior versus more of non-purchase behavior. And once we have that, that means we've been able to come up with the dimensions or the abstraction or the feature abstraction that is now able to separate somebody who has intentions of purchasing in this session versus, and based off of all the historical data that has happened, versus somebody who has not, has any intentions of purchasing. So now, based off of this cluster data, the final outcome will be that we have now a historical model. So now let's say somebody just logs in, I will just re-update the features based off of the pipeline. And then for every single session, we will be able to predict with some probability that is this person going to be purchasing today in this session or not. And that is the most powerful outcome that comes from here.
Right. And
hope that answers it.
I mean,
Sorry.
Yeah. So do you mean that for each cluster, the parameters for each cluster, like the parameter for the models for each cluster will be different, right?
Yes, absolutely. And so using your Tensorboard, your previous the previous ones were without feature selection and with feature selection, and now you're seeing that what the model is the hidden states, what they are showing you. So now you have abstract features as well as explainable features that you are now understand that these are the explainable features that will help you to categorize customer behavior, saying that these have higher propensity of purchasing versus these who don't.
And just as a finish off, if I can, as a comment on the tool, I think this is the most easy clustering, visualization tool I've used in last 1 year. I've been working with data science, easy to use, easy to understand, and even if you start before modeling, you get an intuition of data, like how the clusters are forming out to be. Tensorboard gives you a lot of options to play around with, and I think for data which is of higher than 2-3 dimensions, definitely the tool. I think I'll be going from here for a visualization.
Joachim had a question. He raised his hand.
Yeah, I was maybe it's similar to what was just mentioned, that the interpretation of the clusters, basically, that they weren't mentioned in this presentation, but maybe that's future work, right?
Yes, we will be doing that. Yes. Right now we just wanted to see if there were any clusters or not. The answer is yes, there are, which is good. And now we need to actually deeply go in and analyze what that really means. So how many features of what aspects? Yes.
Exactly. Look at those data points and see what, try to make an interpretation. Another thing, while I have the word here, is that so the LSTM, that incorporates time, right? So does it mean that you look at the sequence of pages more than static features, right? So you could make a prediction as you go, right? It's not depending on the static. Yeah.
So you have to update the features.
Yeah. So it could be used in real time.
Absolutely, it can.
Yeah, that's great.
Any more questions, comments?
Yeah, I have a question.
Sorry.
How do we now take this forward and connect it to Volvo data? Like, what is the next step for us here?
One thing that we want to do is the work isn't finished. So this is very much on cosmetics data. And that is just, we just wanted to start with it because that was a smaller data set. The first thing that needs to be done is this has to be expanded to the electronics data, because then we see the behavior is going more towards what the Volvo Cars data set would be, where people are coming and watching it for a longer time and then deciding if they want to make the purchase or not. So the first step would be to finish an analysis on that. And then once that is done, then the students can open source it. we are hoping to, finish and write everything down. But then after that, the whole, all of the code then becomes available, and then we can try to see in-house as, what that means. So the journey or the pipeline will be fixed, but we can start doing our analysis in-house. So we have Joachim, we have Al, Ibrahim, and me, so we can put our heads together to expand that beyond it.
Ideally, the data could be plug and play, right? If we, the code will remain the same, or the pipeline, hopefully.
I just want to say that we are not ready yet, because this is very cosmetics data set, and this will not scale directly. So the patterns that we see from the electronics would probably scale more. So that's why that's just another step, but we should be able to do that fairly quickly now that we have the machinery in place.
Right. Yes, and it will be very interesting to compare. If we can plug and play the data, we can compare our data with those results and see how these clusters change, or
Absolutely. So the fields, we've made sure that they are very similar, and it's the data is very much Google Analytics, and all of this is very very recent data. Generic. Hey, Jonas, have a question?
Yeah, thanks, guys. I think I just wanted to say one really cool insight that popped out for me was the two things. First, the positive correlation between adding something to a cart and purchasing, and also that as the value of the product increases, people want a cart function. So I think that's a direct insight for high value products like cars. Maybe we should explore something like a cart function.
Right. That's true, because you generally don't do like a buy right now. So even in cosmetics, we saw that there were some cases where people purchase directly. You don't even put it in the cart, you just buy. But of course, as the price of the product increases, the commodity, we actually see that the people are putting it in the cart, and it lasts in the cart for longer. and those activities and behaviors are different. So that's why we wanted to do it on two different data sets and say, if the same pipeline, how are the analytics different? And even if you say that it's passing through the same black box, the analysis has to shift, and then we have to explain why it happened. So that's the beauty of this pipeline that we have in place.
That's
so
a great
for
comment.
Pointing that out.
Yeah, because maybe we by adding more ways for the user to interact with allthecars.com would simply retain the session length and number of sessions, basically. Right. If you can
so these are analytics then,
you could easily I'm thinking about like mood boards, or something similar to a cart. That'd be super cool to explore.
And like that was the kind of intent before mentioning straight about making the black box or the pipeline scalable. So initially we were discussing amongst ourselves, like, do we want to pivot on the user session? Like, do we want to look at something as granular as a user session and make that as our index from where we measure the data? But we found something helpful with cosmetics, because cosmetics as a product, people tend to purchase multiple and tend to make quicker purchase decisions, but that would definitely not scale to a mobile phone, and certainly not scaling to a automobile. So we wanted to look at a customer's interaction or his experience with the product from the end to end, when he logged into or when we started capturing the data until we ended, like what was the behavior like. So we kind of made this like a user ID X product ID, so that how is a person's journey across a product ID looking like, irrespective of like if he has added that product like a number of times or like removed it, like what is the broader picture over here, and not just get hinged upon like how many times he has added that product, because things like phones and cars, they just get purchased one generally, you don't buy multiple of those entities. So we're looking at that, designing a black box or pipeline.
Great. Any other questions? Ikla, please do ask. I can read out his question. So Iklak is asking, a good next step would be to map a cart purchase model to a car purchase model. Perhaps putting into the cart, it's like walking into a dealer. That is, what is the mapping between the two cases?
Yeah, sorry, I was on mute before. I can, I was going to say, first of all, I wanted to just say, really good job on the entire project, and like good job on everyone's behalf. Really, a lot has been accomplished in just 30 days. So that was great. And I also wanted to say that I agreed with the comment before that seeing that that correlation, really the line or the ratio between you know, cart to purchase and views to cart and things like that, that seemed like a really helpful like insight. And in fact, one thing that you can do is probably try to figure out what variables make that higher and lower. So, you know, while that's a kind of a constant ratio, if you segmented it into the ones where the ratio was lower and the ones where the ratios were higher, you might be able to figure out what causes a person to be more likely to buy. Just a side comment. And then in this last comment that I was making was, so right now you've got this model, you've got the model of people put things into a cart and then they, you know, and then they buy them. I was wondering if you've thought much about, not if you thought about, but what was the intention with the car shopping? Did you intend that people will be buying cars like by putting them into a cart, or did you intend that people are still buying it the same way, but that there's that they're going into dealers, but that some of that work is done online prior to, you know, part of that interaction is done online prior to going into the dealer? And if that's the case, then making a mapping between the process that you either actually see or the process that you envision people will use in a different situation back to the kind of states and likelihood of getting from one state to the other be important, because you know it like anyway.
Absolutely.
The point's been made.
Absolutely. Now. Absolutely, and that's what we have as well. So clients actually look online first, and then they end up buying. Or even if it's a subscription model, let's say it's a month-to-month lease, then you would, you know, first look online, and you would probably even have to finish everything online. But yes, getting to that mapping, and that's what we are trying to get at. That even though we are trying with the one black box, it's not one solution fits all. So the analytics is going to change. How you represent or what you do with that data is going to change. But the goal for this project was typically just to create one black box so that, you know, you're able to engineer features at scale. And once you put that in, once whatever you have out, then the process is to analyze that and explain what next after that.
I can just hook in there.
That was exactly the scope of the project.
When I heard that idea right now from Jonas, is that I just like the idea that there are more ways to interact to do. I mean, look, you can like it, or you can, because today there is 2 or 3 forms that you can fill out and order a test drive, or you know, but they should be quicker, smaller things to interact and just go to another page next, or fill in the form, like add widgets and things, because this data set obviously has more actionable features than we have.
Yeah, so we don't have a cart feature, just like Jonas mentioned.
Yeah, or like, or you know, something that yeah, something that is you can just click, and something simple.
Yeah. Well, this is great. I'm so glad that there have been a lot of conversations from the industrial as well as in the academic side. So please keep them coming. You have another follow-up question, Iklaq?
No. Again, I think if we're starting to wrap up, I just reiterate my comment. You can hear me, right? My microphone's on. Okay, good. So I just reiterate those comments. First of all, really good job. I mean, really a lot of work is done. Sohini, I'm going to say thanks to you also. There's no way that so much progress could be made without you know, without your you know, very direct guidance and vision and you know, so forth.
Thank you.
And also, I'll just say on behalf of Berkeley that it's really been a pleasure to be able to try this model. Like, we really enjoy all of our interaction with Volvo in, you know, overall, and to be able to try this kind of like new experiment to see how much could be done in this like discovery 1 month model. So Sohini, you've been a really good partner in like helping us try the experiment. And I would say, as far as experiments go, not only are you finding what makes people buy cars, I think you're also helping us find out what kind of research projects and different models of those projects can be effective for future. So I'll just say thanks overall for the whole thing.
Absolutely. That's what we are here. And goal is not finished yet. We will finish the paper. At the end of the day, that's the carrot. We will finish it.
So Hini, we actually have a card feature in our checkout for the subscription.
Okay, for subscription. Okay, that's good to know. And that's what we're saying, if that could be done the same way for purchase as well. Or even like a particular feature, that would give us more in-tuned information about what the behavior or what the customer actually likes versus the other. But yeah, that's good to know. But then the question is can a person remove from cart as well, or is once you have it in the cart you can't really go back?
No, you can remove it, right? You configure the car, but then you can go back and select another one. So it's kind of like a shopping cart. It's not like Amazon shopping cart. You can add 2 cars and things like that. But in the back end, it acts as a shopping cart.
I see. Okay. And can you change configurations like color or upholstery or anything like that? Are those parts of
you can add mileage? Yeah, you can change
Okay.
mileage. You can add things like winter tires, for example, and that will change the price. So it's basically like a shopping cart.
Okay.
I mean, it's yeah, as Dennis said, it's not very robust, but it's a pretty good shopping cart.
Mm-hmm.
No, it is very robust, especially if you ask Jerry or Vlad.
No, I meant
so
like
that's
Amazon,
good. Then we can definitely
list and save for later and all of that. It's not that, but it's a good shopping cart.
Yeah.
All right. Thanks, everybody. Thanks so much. I think this was great. And like we said, our work is not yet done, but I'm so glad we were able to start this, and we will definitely finish it. And once we do, we'll send out an email to everyone that yes, we have finished it, and this is the conclusion in the form of a paper. So that's what we're looking forward to. So thanks, everybody. Thanks so much for the enthusiastic students. And also I wanted to give special thanks to Joachim, Ao, and Ibrahim. They have been extremely instrumental to it. And, they're the mentors in training. And we see great collaboration in each and every one of the calls. So thanks, everybody, for being a part of this.
Thank you.
Thank you.
Thank you, guys.
From our side.
Okay.
Thank you.
Really appreciate it.
Okay.
Bye.
Bye, guys.